So sometimes we're interested in how fast an object moves around a circle. So the angular speed has to do with how fast it's rotating through an angle, and the linear speed is how far it's traveling. So the linear speed we define as v, and it's an object, and it's moving a distance of s. Now, S, remember, is the arc length, right? S on a circle of radius r, okay, and at a constant speed. Okay, is the distance divided by the speed. Sorry, so by the time. How much time has gone by? And that's t. So we define it as v equals s over t, which is typical when we talk about, in general, we talk about any kind of linear speed, it's distance divided by time. But now we want to know that our distance, this distance s, which we typically call a distance s, has to do with the arc length. Now, angular speed is omega. It kind of looks like a W, but it's an omega. And it's when is the angle, they say swept out, which means how much, you have a circle, right? How much of the angle you go through, swept out, divided by elapsed time. So omega equals theta over t. But let's look at this relationship. So the linear speed is s over t. And remember that s from our arc length is r theta. So it's r theta over t. And notice that theta over t is omega. So it's the radius times the angular speed is the linear speed. So let's look at a couple of examples on how we would use this. So the first one is I have an object traveling on a circle. It has a radius of 2 meters. And in 20 seconds, it travels 5 meters. So that's my S. Okay, that's my T. And that's my R. And I want to know the angular and the linear speed. So I can find the linear speed. V is just S over T, which is 0.25 meters per second. And then remember, my angular speed is just the linear speed, well, divided by R, right? Because V is RW, so R omega, so omega equals V over R. So that's 0.25 divided by, I'm sorry, it's 0.25 divided by the radius, which is 2, which gives me 0.125, and it's angular, so it's radians per second. I have a rye that goes in a circle. It spins at a speed of 22 revolutions per minute. It has a diameter of 13 meters, and I want to know the linear speed in kilometers per hour. So first of all, if it's 22 revolutions in a minute, each revolution is 2 pi. So I have 2 pi times 22 radians per minute. And that's really my omega, right? So then what I have is I have a diameter of 13 meters, but everything we're doing is a radius, so my radius is half of that, or 6.5 meters. So now I have my omega, and remember that V is R times omega, so V is going to be 6.5 meters times 44 pi radians per minute. Because 22 times 2 is 44. Okay. So now I need to convert that to kilometers per hour. So I need, I have meters, and so I have 1 kilometer is 1,000 meters, and that will get rid of my meters. And I have 60 minutes is 1 hour, and that will get rid of my minutes, so I'd have something that's kilometers per hour. And if I multiply all that out, and including the pi, I end up getting 53.9 kilometers per hour for my linear speed. My last example is I have a radius of a car wheel, 15 inches, and it's 3 revolutions per second, and I want to know how fast the car is moving. So that's V again, and so I know my omega is 3 revolutions per second times 2 pi, so I have 6 pi radians per second. And V is R times omega, so that's going to be 15 inches times 6 pi radians per second. And so in inches per second, I have 90 pi inches per second, which is the same as 282.7 inches per second. And now I want to convert it. So I have 282.7 inches per second. I have to get rid of seconds, so I have 3,600 seconds per hour. And I have 1 foot is 12 inches. And I have 1 mile is 5280 feet. So I multiply by that, and I multiply all that through, and I get 16.1 miles per hour.